Welcome back. Today we are going to talk about naming polygons based on things that we know about their angles. We're also going to talk about regular polygons. Okay, so the sum of the measures of the interior angles of a convex polygon. Remember, the sum of the measures of the interior angles is found by n minus 2 times 180. For this particular polygon, we find that n minus 2 times 180 is equal to 1260. Okay, so some polygon has interior angles that add up to 1260 degrees. What kind of polygon is it? So we will divide by 180 and get n minus 2 equals 1260 divided by 180 is 7. And then we will add 2 and get n equals 9. Okay, so that means it is a 9-sided polygon. A 9-sided polygon is called a nonagon. Okay, now typically we use names like this for 3-sided up to 10-sided. So you've got triangle, quadrilateral, then a pentagon, hexagon, heptagon, octagon, nonagon, decagon. Okay, so 9-sided was the nonagon. Usually then for 11, we just say 11gon, even though it's actually called a hendecagon. Usually people just say 11gon. 12-sided is a dodecagon, and that's a pretty commonly used name, dodecagon. But then when we get to 13, it has a scientific name. It's called a triskidecagon. But most people just call it a 13gon, and then you've got 14gon, 15gon. No matter what the number of sides, there is a scientific name for it, but typically we only use scientific names for 3 through 10 sides and then 12 sides. Okay, so now the sum of the interior angles of a convex polygon is 1620 degrees. So that means if you do n minus 2 times 180, you're going to get 1620 degrees for this particular polygon. So you'll divide by 180 and get n minus 2 equals 1620 divided by 180, and you get 9. So n minus 2 is 9, and then add 2, and you get n is 11. That's called a hendecagon, but usually people just call this an 11gon. All right, now let's talk about regular polygons. A regular polygon is a polygon with congruent sides, which means it is equilateral, and congruent angles, which means it is equiangular. So a polygon that is equilateral and equiangular is called a regular polygon. So all the sides of this octagon are exactly the same length, and all the angles of this octagon are exactly the same measure, and that makes it a regular octagon. Okay, so in any polygon, we can do n minus 2 times 180 to find the number of degrees total. But we can do more than that with a regular polygon. With a regular polygon, we can say that each individual interior angle is n minus 2 times 180, which is the total, divided by n, the number of sides. And that gives us the measure of each individual interior angle. So now this is an octagon, so it has 8 sides. So if I do 8 minus 2, I get 6. So it could have 6 triangles in it, times 180. So there's a total of 1080 degrees in that octagon. And if I divide that by the number of sides, which is 8, I get 135, which tells me this is 135 degrees, and so is every other angle in this octagon for a total of 1080 degrees. Okay, so if the base of a lamp is in the shape of a regular 15-gon, so an equilateral and equiangular 15-gon, what's the measure of each interior angle and the measure of each exterior angle? So for this 15-gon, if I do 15 minus 2 times 180, that's the number of triangles times 180, I get the total degrees, and divide that by 15, I will get each interior angle measure. Okay, so that's 13 times 180. It's a total of 2,340 degrees. Divided by 15 angles, I get 156 degrees each. Okay, and then for B, the measure of each exterior angle. Now remember from our previous video, no matter how many sides there are, the exterior angles always add up to 360. And since this one is regular, all 15 of them will have the same measure, so I can just divide by 15. 360 divided by 15 is 24. 24 degrees is the measure of each exterior angle. Okay, now I want you to notice something here. 156 plus 24, that actually adds up to 180. These are supplementary angles. An interior angle and exterior angle on the same regular polygon should definitely add up to 180. So if I make an exterior angle right here, what I actually made is a linear pair. These two have to add up to 180. So 180 minus 135 tells me that this right here, this exterior angle, is 45 degrees. So when you find each interior and each exterior angle, they really should add up to 180. Okay, so we'll do that here for a nonagon. That's 9 sides. So that's 9 minus 2, the number of triangles, times 180 each. That gives me the total number of degrees. Divide by 9, and that gives me each interior angle. So that's 7 times 180 divided by 9, 140 degrees each. Okay, then for the exterior angles, to find each one, I do 360 total, divided by 9. So they share those 360 degrees equally. That will give me each exterior angle. Okay, so 360 divided by 9 is 40 degrees each. And please notice, those are supplementary angles. They add up to 180 just like they should. Okay, and our last couple problems here, given an exterior angle or an interior angle of a regular polygon, classify it. So give a name. So if you have a regular polygon in which each exterior angle is 14.4 degrees, what kind of polygon is it? Okay, so in other words, for each exterior angle, if we do 360 divided by the number of sides, we get 14.4 degrees for this particular polygon. So what kind of polygon is it? Now we're going to treat this as a proportion. So I'm just going to put this over 1 so it looks like a proportion. And you may remember that in a proportion you can exchange things diagonally. So this is really the same as 360 over 14.4 equals n. Okay, so 360 divided by 14.4 is 25. So n is 25, which means that if each exterior is 14.4 degrees, what you have is a regular 25-gon. What if each interior angle of a regular polygon is 160? So now it's interior angles. Each one is 160. Each interior angle of a regular polygon is found by n minus 2 times 180 divided by n. And in this case, it is equal to 160 degrees each. To solve this, let's multiply both sides by n. That cancels. So n minus 2 times 180 equals 160n. Okay, let's distribute that 180. 180n minus 360 equals 160n. Then we can subtract 180n and get all the variables, all the n's on the right side. So we get negative 360 equals 160n minus 180n is negative 20n. And then let's divide by negative 20. So I have negative 360 divided by negative 20, and that is 18. So n is 18, which means what we have here, if each interior angle is 160 degrees, we have a regular 18gon.